equal to 3 moles of oxygen. So if I have which means in order to react this 4 moles, this is what's required. So if I have 0.27 moles of Fe and 4 moles of iron is 3 moles or needed to react with 3 moles of oxygen, that means that I need this over 1 moles iron on the bottom. So this is 4 moles iron, 3 moles oxygen. Because I want to find how much oxygen I would need if iron fully reacted in order to do this. So if moles iron can get canceled out. So it's 0.27 divided by 4 multiplied by 3. This number is, I can't do the mental math. So divide by 4 times 3. It's 0.2 moles. This is how much is required for Fe2O3 using all iron. So it's pretty clear that 1.5 is significantly greater than 0.2 moles. So iron is limiting. But we're not done yet. Usually questions when they ask you to do this. So we did balanced equation, found moles, masses, then we did the mole ratio, and this is another point, found limiting reactant. Let's take this one step further and find theoretical product formulation. In moles and grams. So I said that 0.27 moles of iron is limiting in this reaction. So if I really wanted to find the number of moles of ferric oxide, I would have to really think about, okay, well, if I have 0.27 moles of this, how many moles of my iron is going to actually give me that product? And it takes 4 moles of iron to give you 4 moles of ferric oxide. So we need another molar ratio. So we can say 4 moles Fe is equivalent to 2 moles Fe2O3 as far as this reaction is concerned. So putting this into math, we have 0.27 moles Fe over 1, and we want to cancel out moles Fe. So 4 moles Fe go in the bottom, and 2 moles. This cancels, I divide this by 4, which is around 0.07, and I multiply that by 2. So I'm going to round up and say this is 0.15 moles of Fe2O3. In grams now, I have 0.15 mole O3 and Fe2O3 molar mass is written as 2 times 55.85 grams per mole plus 3 times 16 grams per mole. Which gives you, what is this, 110, 111.7. So it's 111 plus 48. This is 159 or 0.70 actually. Grams per mole. And I think I'll break this stream up and I'll do a couple more videos on different ways you can use Stoich. But this is the amount of moles we have of ferric oxide. So let's go to the next one. Or actually, let's finish this question down here. I have grams per mole. So 0.15 mole Fe2O3 times, this is going to be 1 mole Fe2O3, so we can cancel out these units. And we said this is 159.7. And I'll keep my units written properly. 0.15 times 150, just round it to 0.1 or 160. Times 0.15. It's 24. So we have 24 grams of iron or ferric oxide. And this is the end of this question. So I think wrapping up, I'm going to give quick summary steps. I think this is probably the most important part, and then I'll write future directions over here. Or maybe I'll say question curveballs. So summary steps are 1, balance your given equation. Step after that is to convert everything to moles. And this is important because, very important for partial credit. Sometimes you're doing a question, you don't know the answer. It's best to convert everything into moles because you're just guaranteeing yourself that whoever's reading it might like it a little better instead of converting just what you think you need. Then before determining your limiting reagent, find mole ratio of your reactants. Then find limiting reagent. Once you find your limiting reagent, the next step is find mole ratio of limiting reagent to your product. And then find moles or grams of products. Maybe I will erase this and then one next slide, right, future directions. This would be, I think, a good place to take a screenshot of things because this is the do you write? Do you use your mouse or write with a tablet pen? I write with a tablet pen. I'm using a Wacom tablet that I got as a gift a couple years ago. But you find the moles or grams of your products, and this is kind of the summary steps of finding, like doing a general stoichiometry question. But new page, let's do future steps, future questions, curveballs. Basically, like things to look for. Sometimes they may ask you to do theoretical, and this is very common in lab, versus actual yield. So theoretically versus actual yield, so this is like percent percent yield is quite important. So what they'll do is they'll ask like um, they will give you an actual yield. The question will be posed as, let's say you actually see only 30 grams of ferric oxide. What was your percent yield? That's what they want you to do, is they always want you to find the percent yield. What they can give you are non-gram amounts. So you're looking at things like pressure slash volumes, or they'll give you molarity. And this you can convert through either PV equals nRT if it's a gas, or density as far as volume. For molarity, molarity equals moles per liter. Other kinds of things they'll do are neutralizations. I think I might, after the stream ends, start a second stream where I go over neutralizations. And these are just a specific type of reaction. All right, and I think I'm gonna pause it here. What research am I doing this semester? I'm doing a lot of writing right now, and I'm doing a lot of lab building right now because I'm joining an assistant professor. So most of the work I'm doing is right now just like building up the infrastructure of the lab that we have. So so I think I'm gonna call it